Okay, so today I will be going over the basic trig identities so I can make it easier to understand and memorize. I will show you how to prove the identities, but after you understand the proof, it is essential that you memorize all of them. Okay, so let me start by drawing the unit circle. The unit circle has a radius of 1, and so this will be the initial side, and I will draw a line from the point of the origin to the edge of the unit circle. This is called the terminal side, and this is the terminal point. Okay, so we know the terminal point would have the coordinates of x, y, as would any other point here, like these two. But we also know that it has the coordinates of cosine theta, sine theta, and these are equivalent. Okay, this is because if you draw a perpendicular line from point xy to the x-axis, you have a right angle. This right angle tells us that we can use our SOHCAHTOA rules. So cosine of theta equals adjacent over hypotenuse. This is assuming that this is angle theta, and we know that adjacent is x, and the hypotenuse is 1 because this is a unit circle. So that tells us that cosine theta equals x over 1. Okay, so if we do it with sine theta, it equals opposite over hypotenuse. We know that the opposite is y, and hypotenuse is 1. So sine theta equals y over 1. So that gives us cosine theta equals x, and sine theta equals y. One sec. Okay. X. So from this, we can analyze tangent of theta. Tangent of theta equals sine theta over cosine theta. And since we just proved that cosine theta is x and sine theta is y, we know that this is equal to x over y. You know, x over y is equal to the rise over the run, which is equal to the slope. So tangent of theta is equal to the slope of the terminal line. Okay, so let me show you one more thing before we move on to the identities. So if I draw another unit circle and pick any arbitrary point, it will have the coordinates of cosine theta, sine theta on the unit circle. But if I have a circle with a radius of 2, what will the coordinates be of this point? Well, we know that we would just have to double the coordinates, so it would be 2 cosine theta, 2 sine theta. But what if I have a circle with radius of r, some random radius? Well, we know that we'd have to multiply by r, so this point would be r cosine theta, r sine theta. Yay! Okay, so now let's move on to one of the most basic identities. Cosine squared theta plus sine squared theta equals 1. Okay, let's start by drawing the unit circle again. We know that this is cosine theta, this is sine theta, and this is 1. So if we have a right angle, we know we can use the Pythagorean theorem, which states that a squared plus b squared equals c squared. Well, we know that this is a, this would be b, and this would be the hypotenuse, which is c. So we know this is equal to cosine squared theta plus sine squared theta equals 1 squared, which is cosine squared theta plus sine squared theta equals 1. And from this, we can take that cosine squared theta equals 1 minus sine squared theta, and sine squared theta equals 1 minus cosine squared theta. These will be really important when we start solving these functions, but if you can't remember them, then now we know how to get them. Okay, one very last thing. Since we know now that cosine theta and sine theta are x and y respectively, we can just plug in x and y. So x squared plus y squared equals 1. And x squared equals 1 minus y squared, and y squared equals 1 minus x squared. Also, this is cool because x squared plus y squared equals 1 is the formula for a circle with radius of 1.